Good evening to everyone.
एक्सक्यूज मी सर।
Yeah.
सर ओरल में हमेशा पूछते हैं व्हाट इज द वैल्यू ऑफ एन ईयर, तो ये कोई वैल्यू के बारे में पूछता है और कि अदरवाइज इट इज द डिपेंडेंट ऑन द एफएलए, तो आंसर क्या देना चाहिए सर?
No, it is not dependent on the FLA. In ER value, there is a one regulation is there regarding that. Okay, so you need to calculate as per that. 1 minute. That regulation, I think I have put that one. Okay, I will tell you. Okay, after the break,
Okay.
because I need to search that one. There is a calculation that we need to do that.
ओके सर, ओके सर।
बोला कि हमारा भी सारी
Mute your mic, please. Okay. In your calculation, 1 minute. I have. Okay, I will tell you after the break because there is a one question that has come. In numerical generally we do with FLA, but that is wrong. Because there is a SOLAS regulation that clearly says NER supposed to be this much. Okay, so that regulation I need to tell you first. Then we'll do the calculation. Okay. I'll tell you
ओके सर।
this question. Or just remind me tomorrow, so I'll be ready with that. Okay, mute your video also, please. Everyone, stop the video. Okay. We will continue with same regulation of autopilot. Regulation 29 we are seeing, and this is the para 11. This is saying about the angular position of rudder. So 11.1, it says that if the main steering gear is power operated be indicated on the nav bridge, navigation bridge, nav bridge. Then further it says rudder angle indication, RAI, shall be independent of the steering gear control system. Means the control system and rudder angle indication should be separate. Okay, so it's supposed to be the independent. So there should not be any link with the control system. Second, it is saying that 11.2 be recognizable in the steering gear compartment. Now let's elaborate this one. You might have seen there is a rudder stock. Okay, suppose this is a rudder stock, and there is a mechanical linkage between this, and here you are having the repeat back unit RU number 1, suppose. Similarly, we are having one more RBU number 2. So this number 1, number 2, one for the steering gear number 1. Okay, and second is steering gear number 2. If you see in the autopilot, there is a two system, it is always given. That is follow-up unit number 1, follow-up unit number 2. So when we select 1 and we select number 2. So likewise, if the steering gear number 1 is running, and if you have selected 1, it doesn't mean that it is not going the signal to the steering gear number 2. It goes to that also. But if you are selecting any one, FU1 or FU2, and if number 1 is running and this is standby, that means autopilot signal will come to the control unit of the steering gear number 1, and this feedback is given to that. If we have selected, suppose steering gear number 2, in that case, repeat back unit number 2 is going to give the feedback. Okay, so this is a feedback mechanism. From here, the feedback is given. This is same feedback, that is the rudder position feedback, rudder angle feedback. So this is a control system. Okay, these two are the control system. One more you might have seen along with this. There is one more box is there, and it is written here clearly, rudder angle transmitter. Now, in this RVU, generally we use as a rudder angle feedback, that is the potentiometer. So with this mechanical linkage, this is a mechanical linkage. It may be a control rod or it may be a chain driven, whatever it is there. There is a mechanical linkage between the rudder stroke and the RVU, repeat back unit. So these both are using the potentiometer. Now here, rudder angle transmitter, it is a synchro transmitter. It is using the synchro transmitter here. Synchronous transmitter or synchro transmitter in short. And indicators. From here it will go to the indicators. Rudder angle indicator. This rudder angle indicator, the location. Okay, let's see first what is this. This is a synchronous receiver. This is a synchronous receiver. All indicators. Now where these all indicators are fitted, these all are together, it will be fitted, only one transmitter, and together this all are going to be fitted. At least we can have 5 or 6 receiver together. 5 to 6 number of receiver we can have together wired with this. So first is the steering gear compartment. One indicator will be there. Second, it will be there in the autopilot stand. Third, it will be there in the wheelhouse. That is the flush mounted, or it will be bulkhead mounted wheelhouse. Center of the window, on top of that, you might have seen this is there. Then it will be there in the breeze wing, port, and starboard. This is there at the exit. You might have seen where the bridge wing exit is there. On top of that, you will find this. Okay, port and starboard, bridge wing. So this is also fitted. So this all places, 5 places, this is the minimum. You will find rudder angle indicator that is there. So this is a synchro transmitter and receiver. I hope everybody know about the synchro transmitter and receiver. Do you know about this or no?
No, sir.
No. Okay. This synchro is very old technology, and generally this was used in the World War I. Okay, so it is very old one. This synchronous, once we say, it is same like a synchronous motor only, but it is not a motor. In this, what is there? There is a stator, and the stator is having a 3-phase winding in star configuration. Okay, star configuration. Then there is a rotor. Rotor is a single phase winding. And it is fed with the single phase supply. Generally 100 volt, 60 hertz. Okay, this is the supply it is given. This supply is given through the slip ring and brushes. because rotor is free to rotate. In the transmitter, here in the transmitter, this rotor is mechanically attached to the rudder stroke. Okay, so it is mechanically attached to that, attached to the rudder stroke. Okay. Now, that is in the transmitter. Now, receiver rotor, this is transmitter. The receiver rotor is attached to the dial. Okay, so the dial is having the marking which is going to show the rudder angle. Okay, so this is having the marking of rudder angle. So if you see this one, it is going to have like synchro, as I have told you, the stator. The stator is going to have a stator like this, and it will be marked here like S1, S2, and S3. Whereas there is a rotor, and this is attached with the driven parts. Like here, the rudder is stopped, and it is making the angle theta. So there is a rotor, it is marked with the R1, R2, and this is also given the supply here. That is the 100-volt, 60 hertz, single phase. There is no supply given to S1, S2, S3. That is the stator. Now, when we make the transmitter and receiver, you might have seen the drawing of the synchro. The two circles are there. From this one, it is taken like this. It will be written S1, S2, S3, and receiver is also having same make and model, but it is interchangeable. So synchro transmitter and synchro receiver is same make and model, so you can interchange also. Synchro receiver. So here also we have the S1, S2, and S3. Like this. R1 and R2, that is the rotor. So suppose this is the R1, and here also this is the R1. And suppose there is a R2. So this is the R2. And the supply is given from same point. Okay, from the same point, the supply will be given, not from the individual different separate position. No, same supply which is given to the transmitter, same supply will be given to the receiver, whatever the location. Supply should be given from the same point. Single phase. So this rotor here, it is attached. So this is the angle, it is attached theta So this rotor is also going to show the same angle, whatever the angle it is having here. So how it is working? Working is the S1, S2 and S3. Here the induced EMF which will be there, because now just see how it is working. Okay, I will make again this one. There is the three-phase winding at the 120 degree. So suppose the AS1 is connected to AS1, AS2 is connected to AS2. Suppose this is the AS1, this is the AS2, and this is the AS3. So the connection is like this: AS1, AS2, and AS3. The rotor okay, and this is the R1, and here we have the R2. Again, we have the rotor here. And same, we are having the R1 and R2. So this is connected with the R2, and this one R1 is connected with the R. Okay, and we are going to give here the supply. Here the AC supply we are going to give. So it acts like a transformer here to the S1, S2, S3. But because the S1, S2, S3 is displaced at the 120 degrees, so induced EMF that is going to be sine theta. Okay, so suppose we take the reference here. So here the induced EMF, suppose E1. So E1, whatever the number of turns and all, I am just omitting here. So it is going to have the angle, whatever the value it is going to have, like N, B, A. A is not applicable here because, okay, we'll take this one also. Then omega and sine theta, but this will not come. So whatever the induced EMF here, E1, suppose we say whatever the amplitude is there, we'll say EM sine theta. This will be the supply that will be induced EMF. Here, again, this is going to be the E1. This is the maximum value of the induced EMF sine theta minus 120 degree. And this one, that is E2, sorry. And E3, this will be the EM sine theta 240. So this is going to be the induced EMF. Now, because it is a closed circuit, so the current according to the EMF induced, it is going to flow there. Once the current is going to flow, so it is going to have its own magnetic field, of course, and it is also going to have its own magnet because current starts flowing in this one. So it is going to have its own magnetic field. Now, suppose if the rotor is rotated, okay, and it is going to make a virtual here, the virtual magnetic pole, because all the three currents, they are going to make one virtual magnetic pole, that is the S and N. Now suppose this rotor is having its own magnetic field and this is having the magnetic field and it is also having the pole. And suppose this is the N pole and this is the S pole at this certain angle. So what will happen if the angle is changed here, then it will try to align with this one. It will try to align with this because rotor is free to rotate. So if it is going to align with this one, it will rotate and it will show the same angle, what angle it is moved. So this is how the synchro works. Okay, in this only the rotor is given the supply. Rotor is here fixed, attached with the driven parts, and it will be attached with the dial. So whatever the angle it is here, same angle it is going to show you. Okay, so this is how it works. Hope you understood. Okay. So this is about the synchro. So this synchro will become the synchro transmitter and this will become the synchro receiver. So this is a independent, it is not a part of the control system. This should not be also. Okay. Then we'll go to the next, that is the steering gear number 30, regulation. No, not 30, 29 will continue. Okay, we'll continue. Number 2, this one. Para 12. Okay, para 12. So let's see about this para 12. Para 12 is the regulation for the hydraulic power operated steering gear. Okay. So it is saying about this one shall be provided with the following. So generally we have the electro-hydraulic system. So hydraulic is always there, hydraulic power. So here there should be the arrangement to maintain the cleanliness of hydraulic fluid. So hydraulic fluid should not be laying in the floor, or any leakage is there, it should be arrested. Okay, so that is the arrangement we should have in that. 12.2, it is saying a low level alarm for each hydraulic tank should be provided. Okay, so it must indicate the hydraulic fluid leakage. This alarm should be audible and visual alarm. Shall be given in the nav grease, navigation grease, and also in the machinery space, that is generally it is given in the ECR. Okay, so we can see this one. If any alarm is coming, so we can take action. 12.3. It is saying that we supposed to have a fixed storage tank. And this fixed storage tank should have the capacity to recharge at least one actuating system. Actuating system means a hydraulic actuating system. So one means one tank, we will say one steering gear system. Okay, so full one steering gear system it's supposed to recharge. So this should be the capacity. Okay. And this storage tank should be permanently connected by pipes to steering gear systems. It should be permanently connected. And it should have a indicator, that is the label indicator, that is also known as a contents gauge. Okay. So this is about the hydraulic power operated steering gear. There is a point 13. So 13 it says that it is talking about the steering gear compartment. All the regulations are for different. Okay, so this is about the steering gear compartment. So steering gear compartment, it is saying it should be readily accessible and separated from machinery spaces. That is the engine room. So that's why you might have seen there is a one fire door is there and it is separate. Okay. So it should be separate. Always it's supposed to be separate from the machinery spaces. 13.2, the regulation is there. So here the suitable arrangement should be there to ensure working access, means when we are going to work in this one, so access should be given to steering gear machinery. It should not be compact or space should not be less. Sufficient space should be there. Then they are supposed to be the handrails and grating or other non-slip surface. So that if there is a fluid leakage and people are working in that one, fluid will be leaked or it will drop there. So people should not fall. Okay. Slip and trip should not be there. That's why the handrails and gratings should be there. Now, one question that you have asked me. So this is the one thing it is there. Like if the rudder is stopped, 14, it is about the rudder stop. If it is more than 230 mm dia, if 230 mm dia, if it is there, okay, then there should be the arrangement for an alternating power supply. That means power supply backup should be there. Alternating power supply, that is the backup. Okay. So alternating power supply, and this should supply the steering gear power unit. Steering gear power unit. And this should comply the 4.2. 4.2 para, if you see, this is for the auxiliary steering gear. Main steering gear, that is the para, that is the 3.2. Okay, here it is referring 4.2. So 4.2, it is auxiliary steering gear, 15° to 15° and 60 seconds. Okay, that was the regulation. You can go back again and see this one, 4.2. So it should, alternating power supply, at least it should supply the steering gear power unit, means comply with the 4.2 plus control system plus rudder angle indicator, because these all are independent. Rudder angle indicator. So the supply for the rudder angle indicator also supposed to come. Okay. And this should, alternating power supply should power, means comply with this one, and automatically shall be provided automatically within 45 seconds. So now this is a clear regulation that we have if the emergency generator, which is feeding the ESP. So this supply is going to come from the ESP. That means auxiliary steering gear will get the supply from the ESP. Auxiliary steering gear. Okay, so this is the arrangement generally we have on board ship. Okay. So either we supposed to have the emergency source of power supply, that is, it is saying again in this only, emergency source of electrical power, that is same ESB. Emergency source of power supply, that is the ESB only. Okay, it's supposed to be from ESB plus emergency generator, that is the ESB. And or from an independent source of power. Means suppose we have a diesel alternator only for the steering gear dedicatedly. So we can give from that also. And the location of the independent source of power. Okay, the location of this one supposed to be in the steering gear compartment. Okay, this is the location. It's supposed to be placed in the steering gear compartment itself. And it shall be used only for this purpose, means only for the steering gear, no other purposes. It is continuing this, it is saying that this independent source of power that means it is saying about this independent source of power shall be used only for this purpose. Only for this purpose. Okay. Then Further, it is clarifying about this one that every ship of 10,000 GT and upwards so this 10,000 GT and upwards alternate power supply okay it is not here. I should put the arrow here, means alternate power supply. So this alternate power supply shall have the capacity for at least 30 minutes continuous operation. (30 minutes continuous operation), that is ship of 10,000 GT and upwards, and 4 other ships at least 10 minutes. Okay, so this is the regulation, 30 minutes. Most of the ship like we are sailing, it will fall under this. Okay, so 30 minutes of continuous operation. Hope it is clear. Okay. Then there is a 15, para 15. It says that in every tanker, chemical tanker, when we say tanker means oil tanker or product tanker, that is the tanker. Chemical tanker, only for the chemical, or gas tanker, gas carrier of 10,000 GT and upwards, and in every other ship of 70,000 GT and upwards. So in this case, like if we are having 10,000 GT and upwards and every other ships of 70,000 GT and upwards, the main steering gear shall comprise 2 or more identical power units. That means if we are having 2, then the 2 main steering gear will be there. Okay, identical power units complying with regulation of or comply with para. I'll just write para here, para 6. Same regulation 29, para 6. Now, if you remember para 6, it was saying about 1 minute. We'll go back about the para 6. If it is there. It is, no, it is not here. It will here. It will be here. This one. So this is the para 6. So it is saying that main steering gear if the 2 or more, then an auxiliary steering gear need not be fitted. That means in the tanker more than 10,000 GT and any other ship 70,000 GT will have 100% 2 main steering gear. So there will be no auxiliary steering gear. Passenger ships, whereas it is the operating supposed to be 28 seconds and it's supposed to fulfill the para 3.2 with one power unit. Okay, one power unit. Whereas for the cargo ships, it should be capable with both the power units. Okay, para 3.2. That was the regulation. Then it is also saying that, like I have here highlighted automatic isolation. So main steering gear is so arranged that after a single failure in its piping system or in one of the power units, the defect can be isolated so that steering capability can be maintained or speedily regained. So this is saying, it is not saying automatic isolated, but generally we have the automatic isolation. This will come in the next regulation. One more regulation will come, in that it will be saying about the automatic isolation. Okay, it will say about that. So I don't know why they are making like this regulation. In one place only they're supposed to put. Okay, but this is how the regulations they are making. So this is basically, it is saying about the automatic isolation also. Yeah, now it is coming here. So this is for the tanker of 10,000 GT and other ships 70,000 GT and upward. 16. Para 16. Again, it is saying about every same tanker, chemical tanker. Okay, I will write here tanker at least. And other chemical tanker, gas carrier of 10,000 GT and upwards. Shall comply with the following. So this is the another regulations. In this, it is saying clearly about this one. So it is saying that the main steering gear, it's supposed to be arranged in such a way, that in event of loss of steering capability shall regain in not more than 45 seconds. After the loss of one power actuating system. After the loss of one power actuating system. Now what it is saying, that if the main steering gear shall be so arranged that in event of loss of steering capability due to single failure of any part of one of the power actuating system of the main steering gear. Now here it excludes certain parts. It excludes. So you should know that this is excluded, like tiller. If tiller is fed, we can't do anything. If we have two steering gear, then also because tiller is common. Okay. Or any of such things which is serving for same purposes. If this is going to seize, we can't do anything. Okay, in this case. Or seizure of the rudder actuator. So these all are excluded in that case, which is common for both the steering gears. So anything that is going to seize or something, we can't do anything in that case. So that is excluded. Rest, which is having the duplicacy, duplicate things are there. In that case, it should regain in not more than 45 seconds. Means before 45 seconds, it's supposed to regain. Okay. Then it is again saying 16.2 that the main steering gear shall comprise either, that is the 16.2.1 here, two independent and separate power actuating system and capable of meeting the para 3.2. So 3.2 for the main steering gear, 28 seconds, 35 degree to 30 degree in the deepest seagoing draft and maximum ahead service. Okay, that is what it is saying about this. So either it's supposed to be this, two, or again I'm writing or here, either this or this, at least two identical power actuating systems like in cargo ships acting simultaneously in normal operation. Means in normal operation, both are working, like in the passenger ships. Because if the both the main engine is running, both the rudder will be working together simultaneously. Okay. In normal operation, again, it shall be capable of meeting the requirement that is given in the para 3.2. And if one is, there is a hydraulic power actuating system which is provided, and loss of, if there is loss of hydraulic fluid from one system, shall be capable of being detected and defective system automatically isolated. Okay, so that other actuating system shall remain fully operational. Okay, so here the word has come about the automatic isolation. That's why you'll find in the tankers, generally we have the automatic isolation. Other ships more than the 70,000 GT also having the automatic isolation. Although it is not saying about that one, in any of this, it is saying that it should be isolated, but they have the automatic isolation. So this is about the 60. Now let's go for the regulation 30. Regulation 30. Regulation 30, steering gear regulation 30, this is additional requirement for electric and electro-hydraulic steering gear. Electric and electro-hydraulic steering gear. So regulate para 1, it says about that running indication of motor and steering gear, electro-hydraulic steering gear shall be provided in the navigation bridge and it also should be provided in the ECR. 2. It is saying that if the electric and electro-hydraulic steering gear, now everything is electric and electro-hydraulic steering gear. So I will be not writing again and again. I will just write steering gear. So it is E or electro-hydraulic, EH. Okay, so this regulation is for this one. Steering gear comprising one or more power units okay, shall be served by at least 2 exclusive circuits fed directly from the main switchboard. Now I hope it is clear. Yesterday someone has asked me about this. So SOLAS regulation says that the circuit breaker of both can be in the MSC. So this is the regulation 30 para 2. But further it is clarifying here, it is saying, however, one of the circuits may be supplied through the emergency switchboard. Sorry, emergency switchboard. Okay, so this is the regulation for that. Further regulations are also there in this, that is about the capability and all. Okay. So here, this is about the main steering gears. If they are the one or more power units are there. Now in this regulation, it is also saying about the auxiliary steering gear, auxiliary electric or electro-hydraulic steering gear, if it is there. Auxiliary steering gear is there. Okay. So this is associated, means with the main steering gear, if it is associated with main steering gear, may be connected to one of the circuits supplying this main steering gear. Okay, suppose there is a one main steering gear, one auxiliary steering gear, and this main steering gear, if it is given from the MSB, this also can be connected from the MSB. Okay, that's what it is saying. And the rating should be such that simultaneously it can operate both auxiliary steering gear and main steering gear. So that capacity. Now the para 3, that is very, very important, and there is a many confusion in this. This is saying that short circuit. About the control system, already we have seen there is a short circuit protection for the steering gear control system. Before only it has come. Now here it is saying about the electric and electro-hydraulic power units are there. In that it's supposed to have the short circuit protection and overload alarm. Okay, so this shall be provided for such circuits and motors both. Okay, so this is the one regulation. Second, in this only it is saying protection against excess current, including starting current. Including starting current if provided shall be for not less than twice the full load current of the motor or circuit so protected and shall be arranged to permit the passage of the appropriate starting current. Okay. Now, there is a many confusion in this. Many people says this is saying about the 200% insulation. Is it saying 200% insulation? Let me know. Are you agree with this or not agree? Anyone? Is it talking about the 200% insulation?
No, sir.
No, sir.
Then many people are saying it is a 200% insulation. Let me remind you, this is not a 200% insulation.
But
Okay.
sir, stadium motor cross section area are more, no?
Sorry,
For the stadium motor cross section area are more compared to the other motors.
no, what do you mean by cross section area? What is it? Your steering gear motor insulation class is either B or it is F. Suppose we take the F. So maximum temperature, it is going to be this much only. 200% insulation, that means it will be more than the F, double of this. Remember, when we talk about the insulation, we are talking about the conductor and the ground potential. Between this, how much the separation is there, or how much the insulation material is being used. This is insulation class. What material we use, as per that, we decide the insulation class. Okay, so this is totally different, because if the motor insulation class is F, it can hold only up to 155 degrees centigrade. That's it. Not more than that. It is talking about twice. See here, it is very clearly not less than twice the full load current. Full load ampere, full load current, AFLA. This depends upon the load. That means if the motor is going to be overloaded, okay, then in that case, 200% of AFLA, also the current should pass and nothing should happen to the motor. So it is not talking about the insulation class. It is talking about the overloading of the motor. Okay. Overloading of the motor. Now, then how we are going to achieve this 200% or twice more, not less than, means twice of the FLA. Here, the copper wiring, the winding. So this CU wire gauge. This is the thin gauge we are going to thin. Okay, and number of turns are more than the normal motors. So if it is a thin and number of turns are going to be more, what you said, like cross sections area is going to increase. This is what it is happening. Got my point?
Yes, sir, got it.
So generally, your this motor, steering gear motor, if you see their rating, that means duty cycle, time of rating. So steering gear motor, generally it is given. If it is at the 25% of FLA, it is a continuous rating is there. Continuous rating means duty cycle, duty we are talking about. It is continuous running. Okay, it can run continuously if it is having the load 25% of FLA. Generally, we have this or less than this. Steering gear motor always. If it is going to be 100% of FLA, that means it will run only for 2 hours. And if it is going to be 200% of FLA, in this it is also going to give overload alarm also. It will come, the alarm will come. In this, it will run only for 30 seconds. That's it. It is given in the data sets of the motor. Okay,
Excuse me, sir.
yeah.
Sir, after the 30 seconds, the motor will stop, no?
Motor will not stop, it will burn.
Okay, sir. Okay.
Okay. It is going to burn. But why the overloading is there? Any reason? This motor is designed to run for this one. So practically it should not go to this one. This will go only in case if it is overshooting and it is going beyond the 35 degree. Okay, or something is the rudder is being overloaded or obstructed or something has happened. Then only it will reach to this one. Otherwise, it will never reach to this. Okay, steering gear motor. It's supposed to be because it is designed for a continuous run and it will be running in this. So never say it is a 200% insulation rather than say it is a 200% of FLA. Okay. About the starting current. Generally this steering gear starter, like if it is from the MSP and this is fed to the steering gear, suppose number 1, this is your DOL. So during the starting, it will go to the 6 to 8% of your 6 to 8 not percent times of FLA. Okay, it will go to this, but it is very momentarily, very less. So your circuit is not going to trip. It doesn't trip because we have a thermal types OCR. Bimetallic thermal OCR is there. So it is having a thermal delay. And due to that, it is not going to, tripping will not be there in any case, but it is not going to, this alarm also, it will not give any alarm. So 6 to 8 times it will have, means it will pass like normal DOL starter, it will passage for appropriate starting current, this will be there. It is going to permit that. Now, if it is continuously overloaded, then the alarm is going to be. Now, which is from the ESB, which steering gear, suppose steering gear number 2 is supplied from the ESB. This is a closed transition starter. Closed transition starter. Closed transition starter. We have a star delta closed transition starter also. In this, we are going to have the 4 contactors. In this one, we'll be having not 3 but 4 contactors with 22 ohm resistor of 40 watt. This resistor is also used. Okay, so this is a closed transition starter. If you see the starter circuit, you will see. Or we are going to have a auto transformer starter. Now someone has put the question. I think that person is here. What is the difference between the start delta and auto transformer starter? Is that person is here? No, he is not there. Okay. So for your information, if it is not a closed transition starter, normal star delta starter is there. So star delta starter is a open transition starter. If we are not making it closed transition starter, then it is normally star delta starter is a open transition starter, whereas auto transformer starter is a always it is a closed transition starter. So this is the main difference is there in this one. Second difference will come that how much the voltage is being reduced and how much the current is being reduced. So that is the differences you can put it. Okay, so that will be the difference between the auto transformer and the normal star delta starter. Okay, so this starter we are using. Now question they are asking in this one that why the emergency switchboard which is supplying, although both steering gear power units are identical, we have seen now the regulation. Why one is the DUL and second is a closed transition starter? What is the answer? Anyone? Okay. The answer is like main switchboard. Generally, our generators, their capacity is more than 650 or 700 kVA. More than this we have. A single generator during the passage is sufficient. Okay, this one. Whereas ESB, if it is there, ESB, and if the emergency generator is there, this is our the normal diesel generator, and this is the emergency generator. Generally, the capacity is just 120 kVA, near about this only you will get. Okay. So what happened? If we are going to have a open transition starter, in that case, there will be a current spike. Current spike. That is the one. If it is going to have normal star delta, if it is the DOL, your starting current is very high. That is the 6 to 8 times already we have seen of FLA. So this may trip the generator because this capacity is less. So the ACB, these two are sufficient to trip the ACB of emergency generator. To avoid this one, because already we are in the emergency, and if we are going to start this one, and if it is going to trip, to avoid that, we go for a closed transition starter or auto transformer starter. Hope it is clear. Okay.
Okay, sir.
Yeah, good.
Sir, in this close transition, why we use this 22 ohm, this resistor?
No. Have you seen this star delta starter of that?
Yes, sir.
No. Have you seen closed transition?
No, sir. I didn't see.
Okay. If you see that one, then you are going to appreciate. Let me put that starter circuit. There is a starter circuit. You can take a screenshot, just go through it. Okay, now some other day I will tell you, not today because I need to complete this one. How it is working. Here you can see there is a resistor R22 ohm 41. This is a closed transition star delta starter for number 2 steering wheel. Okay, just go through it. Try to understand how it is working. Otherwise, I will tell you this one. Okay.
Okay, sir.
Okay. Next regulation of this one, it is saying that where a three-phase is used, in this case, single phasing alarm. If it is getting single phase, so single phase alarm shall be provided. Okay. Now, the alarms in this paragraph, whatever the alarms are there, like overload alarms, short circuit protection trip and alarm and trips. So that should be visual and audible. Okay, in any case, on board 6, we have always the audible and visual alarm. And it's supposed to be situated, this alarm should be given to the PCR, and this also should be given to the steering gear compartment. Both. Okay, that's it. There is a regulation. Now, we'll see the autopilot. Okay. This autopilot, we'll see about this one. Let me delete this. We'll go for the straight way for the autopilot. This is the best diagram I have found in the manual. One of the manual, it was given, so I copied from that. And I find this is the best one, which describes everything about the autopilot. Okay. Now here, these all elements are in the autopilot stand. Okay, this is there in the autopilot stand. These elements here, steering gear control system, this is there in the steering gear compartment. And radar is there in the hull. Okay, hull mounted. So this is the outside of the hull ship. So it is made a ship diagram and you can see. Okay, so this is the arrangement generally we have. Okay. Now autopilot, when I was teaching about the PID control systems, PID, and we have seen the example also of the PID. So in the example we have seen, I have told you that there is a auto mode and there is a navigation mode, navi mode. These two are only the PID control. Other modes, like we have the hand mode, that is the with the hand steering, hand mode, and NFU, lever or tiller or NFU mode. Okay, this is a open loop control system. This is a open loop control system. Whereas auto mode and navigation mode, this is a PID control system. Now PID control system, again I am coming back to that one, that is the A, B, C, D. A, B, C, D. There is a 4 functions for any PID control system or closed loop control system, not only PID but closed loop control system. That is the sense, compare. Remember this all. So you can describe any type of control system if you know these 4 functions: compare, respond, and affect. Now suppose, let's start with the mode of the autopilot. So autopilot is going to have two mode of operations. One is known as follow-up mode, and second, that is known as a non-follow-up mode. Non-follow-up mode. In short, we say FU mode, and this one is known as a NFU mode. Now in follow-up mode, we are going to have the 3 modes in this. So it is auto mode, automatic mode, navigation mode, navi mode, and hand mode. And non-follow-up mode is non-follow-up mode. So basically we have a 4 mode: auto mode, navigation mode, hand mode, and non-follow-up mode, NFU mode. Okay, so this is a NFU mode also. Follow-up mode means whatever the command is given from the steering autopilot, whatever the command it is given, it is following that. Command is given, is followed by rudder. Means rudder is moving continuously in that position. Okay, so that is the this mode. This mode generally uses the analog signal. Remember, this is the signal they are using continuously. Whereas in NFU mode, this is using the discrete signal. Discrete signal. Discrete signal that is given by the micro switches. Micro switch. So there is a micro switch attached to the lever or tiller, and when it is operated, the rudder is that time it is going to move, and when it is not operated, it will not move the rudder. That's why it is saying it is known as a non-follow. Non-follow means it is not following the tiller or lever, because this tiller, if you have gone to the autopilot stand, you might have seen that when it is written like this, it is written here the port and it is written the starboard. Okay. and it is basically having a spring in this one attached to this. Not this will be not visible, just I am making like this. It is not visible, it will be inside mechanism will be there. So once you press this side, then what happens? If you are going to press, it is going to make the contact. Okay. So suppose like this, if it is there. So here we have a micro switch attached to this one. And here we have a micro switch attached to this. So when we are pressing this side, suppose this is pressed this side, then this micro switch is going to make, if you have pressed this side, this micro switch will. When the micro switch is making, your rudder is going to move. When you leave this tiller, it will come to the 0, 0 position. Wherever your rudder is there, how much it is moved, it will remain there only. Sorry, that rudder will remain there only. Although this tiller has come to the 0, 0 position, but your rudder will be there only. If you want to make it, suppose we have moved to the suppose 10-degree port, we have moved rudder. Okay, and we have pressed the port side, it has moved 10 degrees, then this has come to the 0, 0 position. Rudder will be at the 10-degree port only. If we want to bring it to the 0, 0, in that case, we need to press the tiller towards starboard. This side, we need to press this side so that again it will come to the 0, 0. Once we leave this tiller, it goes to 0, 0, it will remain at 0. Likewise, means it is not following this one. The position of this tiller, it is not following. Why it is not following? Because of the micro switch. If we have the potentiometer here, it will obey. It will, wherever we are going to put this lever, it is going to move. Rudder is going to move. Okay, but potentiometer is not used here. The micro switch is used. Why the micro switch is used? There is a reason behind it. Okay, so that's why it is known as a NFU mode. So auto mode, navigation mode, hand mode, they are the follow-up modes, whereas NFU mode is NFU mode. It uses the discrete signal. Okay. Now again coming back to this. So auto mode and navigation mode. So auto mode and navigation mode, it is using the PID control. So if you see here, it is a control elements, PID control elements. Okay, so it is written as automatic processing unit. Now, all the PID control systems, they're supposed to have the sensor A. So what it is supposed to sense, basically what the autopilot is doing, autopilot is going to bring the ship's course or ship's heading, sorry, to suppose this is a ship's heading, this is known as a ship's heading. To the set course. So suppose this is a course. This is known as a set course. So it's supposed to make set course is also known as a track. In other words, we say track. So this ship's heading. So steering gear system autopilot, this is going to bring the ship's heading, or it is going to align the ship's heading with the set course. That means we supposed to have a sensor which is going to sense the present ship's heading and present ship's heading that is sensed by the gyro compass or magnetic compass Okay, so this is the two compass that is there, which is going to give the present ship setting. Present ship setting, this will be given only by the gyro compass and magnetic compass. Okay, nowadays one more compass has come, that is the satellite compass, but I don't know how many you are aware about that one. That is the new has come already, satellite compass, not GPS. I'm not talking about GPS. There is a satellite compass. Okay, nowadays it is fitted also on board ship. So this becomes a sensor. So if you see here, there is something written as gyro compass and ETC, means magnetic compass. So this is going to give a feedback. So this works as a sensor, sense. There is a comparator here. So this is the B, that is the comparator. Either we are going to set the course in auto mode or in navi mode. There is a course that is set by the external navigation devices. I will tell you what is the difference between these two. Okay. So that will be coming, this external navigation devices, that is the EGDIS, or there is a radar, that is the ARPA, and there is a something is known as a VMS. So this track course that comes from these devices in navigation mode. Comparator, C is respond. So this PID control elements is going to respond by giving the order rudder angle signal. So this signal that will be coming to the rudder servo amplifier. Now this rudder servo amplifier which is shown here, it may be in the autopilot stand or it may be in the steering gear compartment. This is as per design. So this is not concrete that it's supposed to be only in the autopilot. Mostly in the Japanese made autopilot, this servo amplifier is there in the autopilot stand itself. Whereas some German made or some other steering gear systems are there in this case, like Rolls-Royce and all. So this rudder servo amplifier that is there in the steering gear compartment. Okay, so that depends. Wherever it is, this rudder servo amplifier, this is going to control the steering gear control system and rudder is going to be steered in that direction. Okay. Now there is a RBU unit. I have told you about the RBU. So whichever the RBU is there here, this RBU that is going to give a feedback signal. So this is the rudder angle position, rudder angle position. So this rudder angle position that will be given to the rudder servo amplifier. So this comparator is also a part of the rudder servo amplifier. Yeah. So this is the present rudder angle position that will be given to the rudder servo amplifier. So this is the servo control. Servo control is also a closed loop system. Okay, so always this feedback will be given. One feedback that is coming from the gyro compass to the PID control, and this is also a closed loop system. So present position of any driven, okay, any driven parts that also will be given to the servo amplifier. Always it is given. Let it be the generator engine governor is there, or main engine governor is there, or your rudder is there. Wherever this servo amplifier is there, it is going to have a feedback. Even like your control valve, which is the electrical type, that is also having the feedback. So actuators, amplifiers, so they have to have the feedback and that feedback will be coming. So it is thumb rule that all the amplifiers will have the feedback. Okay. So now here if you see the auto mode, navigation mode, it is using the PID control element. Now suppose if this is failed or something has happened, anything like gyro compass fails, or this here this PID control fails, comparator fails, whatever it is going to fail, in that case we can switch over to the hand mode. Hand mode in this we are going to have here the potentiometer. Basically, it is having the potentiometer attached to the shaft of this wheel. So here we are going to move this one either the port or the starboard. So 35-degree port, 35-degree starboard when we are moving. So this potentiometer, the signal, it will be going directly to the radar servo amplifier. Directly. And so the radar is going to be steered in that direction. That means radar is following directly to the steering wheel. Same like our car, it is also following same, similar to that. Okay. Now suppose this also fails, radar servo amplifier. Then we have the last option, that is the NFU lever, non-follow-up control. Now this is directly controlling the steering gear control system. Now here the steering gear control system, when we are talking about the electro-hydraulic system. In that we have the directional control valve. So this is a solenoid operated. Directly we operate the solenoid from the micro switches. Now you got the mind and means now your doubt might have cleared why we use the micro switches. Because this micro switches directly operate the solenoid of the directional control valve. So radar is going to move in that direction. And once the micro switches is off, that time there is no signal. So radar will stop in that angle only. That's why it is known as a non-follow-up control. Okay. So at least you know now that in the autopilot we have the 4 modes: auto mode, Navi mode, that is going to be use the PID control system. Okay, and the other modes, that is the hand mode, that is also a follow-up mode. In case of failure of these 2 modes, it directly controls the radar servo amplifier. Even if that is failing, that means NFU lever is the last option. Directly it controls the steering gear control system. Okay, any doubt to anyone in this? Now let's see about the autopilot system. So that is the autopilot PID control for auto steering. Okay, so I will just give you this diagram. So you can go through this. This is simplified one. I have made it for the auto and navigation mode. Okay, I have not told you what is the auto mode and navigation mode. Auto mode, now suppose if we are going to move, suppose this is the start position of the ship and this is the destination. Okay, this is the destination and this is the start position. Ship is moving from here. Okay, so this is known as a waypoint 1, waypoint 2. This we are making in the egg dish. Waypoint 3, waypoint 4, waypoint 5. Waypoint. So this route map, this is known as a route map. This is made in the egg dish. And egg dish radar, radar AIS, AIS These are integrated system, means they are interfaced. Everything what is coming to the ECDIS, that also will be coming to the radar, and same thing will be going to the AIS also. So these all are integrated system. If we are having the standalone computer, some ships we have a standalone computer that is known as a voyage management system. Voyage management system. Management system. This is a standalone computer. And all the data, navigational data that is coming to the VMS. That means we can say VMS is also integrated. All the navigation data like gyro, okay, you can say like gyro compass signal, magnetic compass signal, GPS, lobe, okay, then echo sounder, wind speed and direction. So these all, even the autopilot, that information. So these all are information that is given to the VMS, ECDIS, radar and AI. Now, if the ECDIS, radar and AIS, they have the route map, that means, and they know about the ship's present position. So in auto mode, when the ship is going to reach to the waypoint 2, so the set course, this set course was here, suppose this is 90 degree. Here the set course, if you see, it is 45 degree. Whereas here the set course, it is 00, and again it is 90 degree here. So when the ship is reaching to the waypoint 2, waypoint 1 means it is having a lat and long here. Then waypoint 2 will be having different lat and long, waypoint 3 different lat and long. This is how we make the route map. So if the ship is reaching here, ECDIS is also knowing AIS, okay, we leave the AIS apart now. Okay, that means radar, ECDIS and VMS, these all three equipments are knowing what is the current position of the ship and where it's supposed to go. In auto mode, the navigator, that is our navigating officers, navigators, they are changing the course. They are changing the course. Okay, they are changing the course. Like if the ship is reached there, now the course will be changed to the 45. If the ship is coming here, it will be changed to the 00. If the ship is reached here, it will be changed to the 90. But in the navigation mode, this changing course will be done by the ECDIS, radar, or VMS. If VMS is there. Otherwise, ECDIS and radar is sufficient. So this ECDIS and radar is interfaced with the autopilot in case of navigation. Okay, hope it is clear. Okay, so this is the navigation mode and the auto mode. Whatever the mode is there, your set course will be done either by the, somebody is writing here. Okay. I do not write anything because this will give a issue. Okay. Okay. So in the auto or navy mode, the set course, either it is going to be done by the navigator or by the external navigation device like AXDIS or radar. That will come comparator where the compass or GPS that will be giving the ship's heading feedback, PID controller, radar servo amplifier, actuator that is the directional control valve, radar that is going to move the ship, and that will be sensed by this one. So this is the sense, compare, respond, control output. So the net effect that radar is going to turn the ship so that the ship's heading will be at the set course. So the ship's heading will come to the set course. So A, B, C, D, sense, compare, okay, respond and affect. Now this part what I have shown here, this part, this is as per the regulation, this is a independent system. It is a independent system. This is not a part of control system. This is a control system, but this is a independent system. Just I have put because the autopilot is also having the radar angle indicator. So how it is indicating in the autopilot stand. Autopilot stand is also having a bearing repeater. This is also not a part of the control system, but this is a indicator. So from the compass, whatever the compass it is selected, that bearing repeater is going to show that heading, ship's heading, as per that. So generally, we select the gyro. Gyro is by default, it is selected always. So that's why we say gyro repeater. So this repeater, which is going to show in the autopilot stand, that is the ship's heading indicator. It is just an indicator. So ship's heading that will be indicated, and radar, how much it is moving, that also will be indicated in the autopilot. Otherwise, your control system is only this much. Only this much. This is your control part. Let me make it with the green. So this is your control parts. This will be your control part. So if you are making this much diagram, this is more than sufficient. Okay, this is the control part. Hope it is clear. Any doubt to anyone in this? Okay. Then let's see quickly about the hand mode or manual mode. So manual steering gear that is there. If you see this one, this is the manual steering gear. So manual steering gear does not have any feedback because it is not a PID control system. So feedback is not required in that. So directly it is controlling your radar servo amplifier. It is directly controlling this radar servo amplifier. Okay. And in the NFU mode, again, NFU mode is going to be smaller than this. This is going to be your NFU mode. So in this case, we are having the NFU lever, micro switches that you use. Directly it controls the actuator. Hope it is clear to everyone. Any doubt? Okay. So tomorrow we'll see the basic electro-hydraulic steering gear system, how it works. This question was asked in the oral. Okay, if some engineer, chief engineer comes, they are asking this question, how it works. We'll see this basic electro-hydraulic steering gear systems. Okay, and we'll try to understand this. Then there is one more question that is coming about the automatic isolation. So how this automatic isolation happens, that also I will tell you tomorrow. Okay. So up to here, any doubt to anyone? One question that is remaining, remind me, that is NER calculation. Tomorrow I'll tell you, just remind me. Okay. So first we will see that one, how we do the NER calculation and what is the regulation, SOLAS regulation for the NER. Okay. I will let you know.
Excuse me, sir.
Yeah.
Sir, I have one question, sir.
Yeah, tell me.
Sir, in electrical terms, sir, why tanker is different than other ships, sir?
Because tanker is the hazardous, more hazards than the other ships.
No, sir, in electrical terms, sir.
In electrical also, there is the electrical hazards like sparks and all that is positive.
Okay, sir.
Okay,
Okay.
explosive, EX. Okay, explosion hazards, that is there.
Okay, sir.
So that's why it is different.
Thank you, sir.
Any other doubts?
Sir, can you please scroll upside? I need to take a screenshot of hand steering, sir, diagram.
Okay, that's
Thank
it.
you, sir.
Thank you. Thank you very much. Good night to everyone.
Thank you, sir. Good night.